everybody. I miss seeing you all, but I guess it's going to be this way for a while, but hopefully we'll get to see each other a little bit in our meeting on our Google Meet that I'll send you an invitation to for Wednesday's class at 2 o'clock. So it's been a long time since we've had class. If you might remember, what we did up through the Wednesday before spring break was we covered up through 7.3, kind of focusing on this single factor block design, sometimes known as the RCBD, randomized randomized complete block design. And so we're going to carry on that a little bit. First, let's talk a little bit about your quizzes. I got your quizzes and Moodles. I have all your quizzes, but I don't think I'm going to take the trouble of scanning them and sending them all to you. I'm just going to attach the quiz and your solutions to the email I'm going to send you, and just to discuss it a little bit. I mean, you did a great job on the quiz. A couple of folks had problems. I guess there was kind of two issues. One, I really couldn't figure, but maybe there was a data entry wasn't quite the same. One or two of you were getting slightly different answers than I got. And then the other thing that can happen is, remember, if you do Minitab, most of you seem to be liking to use the Minitab. If you use the Minitab, you have that weird thing that you have to, after you put both your factors in, you have to go to model and you have to click one of them at the top and one of them at the bottom and then hit the add, and that's what you need to have to be able to put that interaction in, which of course you needed to do to be able to do that correctly. In any case, let's move on. So what I'd like to do is, first of all, talk a little bit about what some of his discussion 7.4. Now, of course, the reading becomes more important, and fortunately, I think we have a really good text to read. I'm enjoying kind of going over it again. And so let's pick up on a discussion that he has on 7.4. He has a lot of really good points there. I think some of them we have already kind of discussed, but I want to kind of go into one or two that we haven't really done too much with. If we did missing observations, things would get complicated. This is Zay. If we did missing observations, things would get a little bit more complicated. You no longer have what we call a balanced design. And so actually, there are different, in that case, there are different sums of squares that you could use. One could be like a sequential sum of squares where the first factor listed would get as much of the variation as possible, and then whatever's left over would be apportioned to the other factors in order. Or you could do what's called a type 3 sum of squares. In a type 3 sum of squares, you try to adjust for each of the other factors kind of jointly when you do it. And the weird thing about those is they don't always add up to the total sums of squares. But let's not go there now. Hopefully we'll have a chance towards the end of class to look at a situation where we have one of these unbalanced design, whether it was because of missing values or whatever. You just have unequal sample sizes in the different, rather than have one, you might have two n equals 2 for some combinations and 1 for others and things like that. Let's move on down. I think we talked about time order and interference effects already. Let's go on down. The one thing that we haven't really talked about that I think is really good, is important to talk about, is this C, loss of degrees of freedom. Whenever you do a block design, it's really a trade-off. You're having an advantage and a disadvantage of using that block. If your block really explains a lot of the variability in the data, it's a good thing to do. Because by reducing that variability, you're going to reduce your sums of squares for error. It's going to give you more power to detect true differences amongst your factor levels. But if that blocking variable really doesn't explain a lot of the variability data, it can actually harm you a little bit, because what will happen is when you include that blocking variable, you lose your degrees of freedom for a given level, for a given number of experimental units. So it's kind of a trade-off that you really wouldn't want to use a blocking factor unless it really does explain a fair amount of variability in there. All right, let's talk about D also. And D, and we're going to go into a little more detail on that one. But in a lot of situations, in the situations where you're kind of splitting up your units, or I'm sorry, reusing your units, like what we might do where we have a single subject trying 4 different recipes or something like that, in that case it really makes sense that you're only going to have 1 unit per block treatment combination. But in a lot of cases, like where you're sorting them, like into 3 age groups, and then you're assigning your treatments within each of the age group. Your block is age groups, your treatment might be your medical treatment or whatever. In that case, you'll typically have replication. And we're going to talk a little bit about how you can do that, where you have multiple experiment units within blocks, actually. Okay? So, and I guess that's really more E that I'm talking about. D is that same situation we talked about earlier, where you're having multiple observations on each experimental unit, so you're having a different number of measurement units as you are for experimental units. So we've already talked about that a fair amount. So let's move on down here. And we're going to talk a little bit about random block effects. We've talked a little bit about the difference between a fixed factor and a random factor. In a fixed factor, all the levels of interest in that factor are of interest to the investigator. You really care about the actual levels of that factor that you did that you used in your study. In a random factor, and this could either be a blocking factor or a treatment factor, more typically for blocking factors, but it could be for treatment factors as well. In a random factor, you can think of the levels that are chosen for your experiment to be randomly selected from a large number of potential levels. And in that case, if you think about it, there's really more variability in the process than you're analyzing in your experiment, that you happen to get these levels to study, but you could have gotten other ones. That's going to increase the variability somewhat. We're going to talk a little bit more about that as we do in our next example. So what I would like to do now is let's go to an example that I think we can actually already have here, an example where we have multiple units on each block treatment combination. And when we did that study of the coin tossing, we said, well, when we did it as a 2-factor design, and we said, we think that we really care about these 3 throwers. But really, more realistically, if you were to do this study, you would just be using thrower as a block. That you don't really care which thrower is best. You really care about what's the effect of the distance. Is it, in your farther distances, is that going to cause your coins to land farther from the wall in the end? And so let's now reanalyze that data as a blocking or RCBD, where the blocking factor in this case is, try that again. That's not the one I want to look at. I want to look at this one here. I keep doing the wrong one. There we go. So this is a study where I think it was Charlie, Justin, and maybe Cage doing this one, that where everybody had 2 throws from each distance. So this is an example. If we think of thrower as the blocking factor, and the distance that you're throwing from as the treatment factor, this is the case where everybody had n equals 2. There's 2 replicates for each block treatment combination. We could call this an RCBD with replication, or in the book he refers to this as kind of a special case as GRCBD. So once you've done this, if you have this kind of thing, if you have replication, now you can look at replications. And so, in fact, we can actually, to do the analysis, you would do the exact same thing as you did when we thought of it as a two-factor, true treatment factor study with interactions. You could do that exact same analysis. That would be the case if you thought of your tosser as being a fixed factor. Think about it for a second. Do you think in this case tosser really would be a fixed factor or whether it would be a random factor? And then when I say think about things, I think it's just a good general idea to pause and just think things over. I think in the long term you'll get more understanding if you kind of think through these issues before you hear me talk about them. In any case, here's my answer to that. I would normally think that tosser would be a random factor because I don't really care about these three specific tossers. I really think about these as kind of tossers that happen to volunteer from the potential of all the potential tossers. So I tend to think of it as a as a random blocking factor. Well, interestingly enough, if you in fact have multiple observations and then you really get a very different analysis. All right, I think because of time's sake, because this takes a long time to load and unload, I'm going to cut this off. I'm probably going to break it up into 3 different lectures. So I'm going to stop this now, and then what I'm going to do is, in the meantime, if you want, you could take this data and analyze it the way you've done before. And when we pick up, we're going to pick up our Minitab analysis of this data.